Assalamu alaikum, dear students. Today our topic is oxoacids of phosphorus. First, what is an oxoacid or oxyacid? An oxyacid is an acid that contains oxygen atom linked to hydrogen atom and any other and any one of the other elements like it is also called oxoacid. So whether we write oxyacids or oxoacids, e.g. H2SO4, sulfuric acid, H3PO4, orthophosphoric acid, HNO3, nitric acid, etc. All these are the oxoacids or oxyacids. तो ऑक्सोएसिड्स में एक जो ऑक्सीजन एटम होता है that is linked to the hydrogen and any one of the other elements. So this oxyacid is also called oxoacids. Examples of this oxoacids are sulfuric acid, H3PO4, and you see in these acids the oxygen is linked, and here in H2SO4 it is linked. Oxygen is linked to the hydrogen and sulfur. Here it is linked to the phosphorus and hydrogen. Here it is linked to the hydrogen and nitrogen. So this was all about oxoacids or oxyacids. Now we have to write the oxoacids of the phosphorus. There are a number of oxoacids of the phosphorus, but important, some of the oxoacids of phosphorus along with oxidation state of phosphorus and their basicity structure and basicity are as follows. तो कुछ इम्पोर्टेंट ऑक्सोएसिड्स फास्फोरस के हम यहाँ लिखने जा रहे हैं. हम इनका स्ट्रक्चर और ऑक्सीजन फास्फोरस का ऑक्सीडेशन स्टेट उस पर्टिकुलर ऑक्सोएसिड्स में भी लिखेंगे. नाउ नेम, फार्मूला एंड नेम of the oxoacid, formula, oxidation state of phosphorus, structure, and then we will write their basicity. Here it is serial number 1. So number first is that we are going to write is phosphorus acid. Its formula is H3PO2. Now, if we write the oxidation state of the phosphorus in this, oxygen in the compounds in which other atoms are less electronegative, it is in -2 oxidation state. तो ऑक्सीजन का हम यहाँ पर ले लेंगे -2 और -2 -4. तो हाइड्रोजन इज इन +1 ऑक्सीडेशन स्टेट, तो -4 का में से निकालेंगे +3, -4 में से +3, बिकॉज हाइड्रोजन when it is with the oxygen in the compounds except hydrogen peroxide, it is in +1 oxidation state and oxygen is -2 oxidation state. So हाइड्रोजन एक का +1 और 3 का +3, तो -4 में से +3, तो वहाँ पर -1, तो the compound as a whole is neutral, so the phosphorus must be -1, so that this whole comes equal to 0. So the phosphorus in H3PO2 is in +1 oxidation state. Now, what is the structure? And the structure is that P double bond O, OH, H and H. This is H3PO2 and its basicity is the number of OH atoms, OH group in the formula in the compound, that is H3PO2, that is 1, so it is monobasic. Now, second, orthophosphorus acid. Or simply we can write phosphorus acid, it is H3PO3. The oxygen is in -2 oxidation state, -3 into 3 into -2 is -6, +3, so the phosphorus must be in +3 oxidation state, so that the overall charge of the compound is 0, it is +3, and the structure is P, it is double bond O, OH, here again we have OH and hydrogen. So in this orthophosphorus acid we have 2 OH groups linked to the phosphorus, so its basicity is, it is dibasic. Basicity is 2, so it is dibasic. Number 3 is orthophosphoric acid. It is H3PO4 and oxidation state of the phosphorus in the compound orthophosphoric acid is 2 4s are 8 minus 8 plus 3 hydrogen plus 1, 3 hydrogen plus 3. So we have to add plus 5 so that the compound as a whole becomes the neutral. So the phosphorus is in plus 5 oxidation state and The structure of the compound is phosphorus, O, OH, OH and OH. If you see in the structure, we have 3 OH groups linked to the phosphorus, so it is tri-basic. Number 4 is peroxomonophosphoric acid. It is H3PO5, and first we will write the structure. Its structure is O, OH, OH and O, OH. Again, it is tri-basic, and here these are peroxide oxygen atoms, so the two have -2 oxidation state. So -2, -2, -2, -2, it is 2, 4, 6, 8. 8 में से 3 निकालेंगे, so it is in +5 oxidation state. In some books it is shown as -7 but +7, but it is +5 oxidation state. And number 5. In number 5 question, we have pyrophosphorus acid. It is H4P2O5. H4P2O5. Again, first we will write the structure. This is POP, double bond O, OH, H, OH, H. Is H4P2O5. 1, 2, 3, 4, 5. In the group, we have how many OH groups? We have 2 OH groups linked to the 2 phosphorus atoms, so it is dibasic. And if you see the oxidation state, here the oxygen is -2 to -10. हाइड्रोजन +1, 4 हाइड्रोजन +4, 10 में से 4 निकालेंगे, दैट इज 6 +6 को 2 से डिवाइड करेंगे, दैट इज इट इज इन +3 ऑक्सीडेशन स्टेट. द phosphorus in H4P2O5 is in +3 oxidation state. Now, of pyro we have 6 hypophosphoric acid. It is H4P2O6. H4P2O6. Now it is oxidation state. 2, 6 are 12, -12, 4 + 4, 12 में से 4, -8 divided by 2, -4. So P must be in +4 oxidation state, so that the compound becomes neutral. Again, this is -12 +4, and this is +8, and for total is +8 for 2 phosphorus atoms, and for 1 we are writing the oxidation state of the phosphorus, that is A divided by 2 plus 4, and the structure is like this. Here, 4 OH groups are linked to the 2 phosphorus atoms, therefore it is 4 OH groups, it is tetrabasic. Tetrabasic. So this was hypophosphoric acid. Now after hypo we have pyrophosphoric acid. Number 7, pyrophosphoric acid. Its formula is H4P2O7. Now the oxidation state of the phosphorus is 2 7s are 14 minus 14 plus 4 हो गया. 14 में से 4 निकालेंगे, माइनस 10 को 2 से डिवाइड करेंगे तो माइनस 10 आता है. तो P2 must be plus 10 so that the compound becomes the neutral. So P2 plus 10. So the oxidation state of the phosphorus will be plus 10 divided by 2 is plus 5. And the structure of the compound is P double bond O, O, P double bond O, OH, 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 OH. It is P H4P2O7, H4P2O7, 1, 2, 3, 4, 5, 6, 7. So in H4P2O7, that is pyrophosphoric acid, we have 4 OH groups linked to the 2 phosphorus atoms, so it is tetrabasic. Tetrabasic. The compound is tetrabasic. Now we have metaphosphoric acid. Next is metaphosphoric acid. It is HPO3. This HPO3, in HPO3, although it exists in the polymeric form and it exists in the cyclo number 1, it exists in the cyclo trimetaphosphoric acid. And number 2, linear polymetaphosphoric acid. So its formula is HPO3 whole thrice. This is HPO3 n times. तो अगर हम इसका ऑक्सीडेशन स्टेट ले लें फास्फोरस का, इन HPO3 ऑक्सीजन इज इन -2 -6 +1, तो phosphorus must be +5 so that the compound as a whole becomes neutral. So phosphorus is in +5 oxidation state, although it is unstable and exists in the polymeric form, but its structure can be like this: P double bond O, double bond O, OH, and it is monobasic. Though it does not exist in the metaphosphoric, does not exist in the form, in this form, and exists in the cyclotrimetaphosphoриc acid. So in the cyclotrimetaphosphoриc acid, again we have 3 molecules of the metaphosphoric acid linked together in a cyclo group, and therefore the oxidation state is +5 again, and the structure is like this. Here this is oxygen and this is OH, and this is OH linked to this, then we have double bond, again we have OH, we have double bond. तो अगर आप देखेंगे HPO3, अगर हम ये ले लें HPO3, ये another molecule, this is HPO3, this is another molecule, three molecules, therefore this is trimetaphosphoric acid. So this forms cyclotrimetaphosphoриc acid, and the oxidation state of the phosphorus is the same as in metaphosphoric acid, that is +5, and again it is, the basicity is that of one unit, that is metaphosphoric acid. In the metaphosphoric acid it is monobasic, so in this it is tribasic. So here this its basicity is 3. So it is, basicity is 3. It is tribasic. Now we will take the structure of its oxidation state is again +5, and we will write its structure. Its structure is like this: P double bond O, this is OH, and again we have double bond, but to this oxygen we have another molecule of PO3. Again we have oxygen, here again we have oxygen, we have phosphorus linked to the double bond, and OH again linked to the another molecule. So अगर आप देखोगे, this is HPO3, one molecule, HPO3 another molecule, HPO3 another molecule. So it forms a polymer of the monomer metaphosphoric acid. Is a polymer of metaphosphoric acid. So the linear polymetaphosphoric acid HPO3, and it is basically is, we are taking it as unit, that is metaphosphoric, it is monobasic, and it is oxidation state of the phosphorus is +5 in the linear polymetaphosphoric acid. So these are some of the important oxoacids of the phosphorus, and in this we have written their formula, we have shown their oxidation state, their structure, and their basicity. Thank you.